All right. Pre-calc. Well, I am out today. This is Friday, April 1st. Not a joke. And we have one more little topic to go over before this quarterly. So I want to go over it with you. We'll go over it right before the quarterly again if you have any questions. But the solving is nothing new. These two problems are going to use a trig equation to solve, right? So the math is not new. It's just in the context of a real world situation. So let's tackle that. Okay. An airplane is asked to stay within a holding pattern near an airport with an average distance of 150 miles. So that's A. Okay, this average distance is 150 miles. The function below represents the current distance in miles of the airplane from the airport at time t in minutes. Now we know that Pavlovian response to word problems is label your axis. Okay, so let's digest this problem. The function below represents the current distance from the airport. Distance from the airport. Okay, I'm in a holding pattern 150 miles close to the airport, away from the airport. So it's a distance from the airport, and on the x-axis is time in minutes. Okay, so this is a sine function. I've got a midline, right, of y is 150. That's what midline is, right? And it's a positive sine function that is really, what do you call it? So it's got a half the frequency. The b value is 1/2, right? It's going to change the period of my graph. And the amplitude, so if this is 150, this is 220, and this is 80, right? Because we've got a sine graph. Okay, so now you notice I am only drawing half a sine graph because in 2 pi, I will only have that much of a graph. Okay, so there's my graph, a really light sketch. What is the first time the plane is exactly 115 miles? Now let's draw that. 115 miles this is 150, so 115 is going to be right here. Y2 equals 115. All right, so when does this occur? Now this graph is going to come down and cross that here. Okay, so when on the x-axis is the first time that happens. All right, let's solve this problem manually. Okay, what is the first time when the plane is exactly how much distance? 115 miles from the airport. So it's telling me that d is 115. So I say 115 equals 70 sine 1/2. This is theta, right? Or x. Or it's t because it's a word problem, but it's operating like theta. Okay? Plus 150. All right, so I've sketched my situation out. Now I'm just doing the math. I'm going to subtract 150, right? Subtract 150, subtract 150, subtract 150, and I get negative 35. Negative 35 equals 70 sine 1/2 t or theta. Now notice what I'm doing. I am isolating the trig expression. That's where I'm going with this. Now I'm going to divide by 70, and I'm going to get negative 1/2, right? 35 divided by 70 equals the sine of 1/2 theta. So I have a multiple angle problem. And now I have isolated. And now I'm going to evaluate from my understanding of the unit circle, right? We've been here many times recently. So we say, okay, what is the angle theta that has a sine of negative 1/2? Okay, well, 1/2 theta, 1/2 t, or the angle, is, where is sine negative 1/2? 7 pi over 6 and 11 pi over 6. Well, I'm solving, those are my, on the unit circle, now I'm going to get my original solutions by multiplying both sides by 2. Okay, because I want to get rid of that 1/2. So I multiply by 2, multiply by 2. When I multiply both of these angles by 2, they 2 and 6 reduce, and I get 7 pi over 3, and 11 pi over 3 equals t or theta or x. Okay, those were my solutions. Those are my x values. We need to answer this in the context of the problem. What is the first time? That is the answer that I need. Okay, so but it's 7 pi over 3 is not a time in minutes, so I literally just plug that into my calculator. 7 times pi divided by 3, right? 7 times 3 is about 21 divided by 3 is going to be 7 something, right? So when you put that in your calculator, you get 7.3 minutes. Okay, so it's very much the solving you are very familiar with, but answering it in context. The plane will be exactly 115 miles from the airport in 7.3 minutes. Okay, the plane will be 115 miles away. That was my D value in 7.3 minutes. Okay, let's do another one. I've changed this problem a little bit. And I've changed this value. So my problem is that Jack is bouncing a ball to see how high he can get it to come up off the ground. It bounces at an angle off the ground at a velocity of 10 feet per 10 feet per second squared. It lands 1 foot away. Find a possible value of theta if the horizontal distance of the projectile is given by this formula. Let's draw a sketch. Okay, so here's what's happening. Jack is bouncing the ball. This is the height of the ball. This equation, height, and I should have made that an H, but all right. It bounces at an angle of theta at a velocity. It lands 1 foot away. So this is the distance away from, this is the horizontal distance, D, of a projectile is given by this formula. So this is the horizontal distance, okay? And it's going to, what's going to happen is the ball's going to bounce, and it's going to come and bounce 1 foot away. So this is the angle that it's bouncing off the ground. And this is my equation. So it's telling me, it's giving me a velocity, okay? And we're trying to find D. So, well, actually, we're not trying to find D. We're trying to find theta. They've told us that D is 1, it's bouncing 1 foot away. So this isn't exactly that's what's happening is the ball is bouncing, but they've told us that the D value is 1. So I'm going to plug in 1 equals 1 over 50. Now, they've told me the velocity is 10 feet per second squared. So I put in 10 squared sine 2 theta. So you have the question, you plug in your variables, and now you solve for theta, just like you know how to do. Okay? So I get 1 equals 100 over 50 times the sine of 2 theta, another multiple angle problem. 1 equals 2 sine 2 theta. And now we're getting into familiar territory, right? We know how to solve this. Divide by 2, 1/2 equals the sine 2 theta. Okay, now we're just on the unit circle. So what does 2 theta equal? It equals, what angles on the unit circle have a sine of positive 1/2? Well, pi over 6 and 5 pi over 6. But I am a double angle, so I'm going to divide by 2, right? And so I do divide by 2, divide by 2, divide by 2, divide by 2, and I get the original solutions. Theta equals pi over 12 and 5 pi over 12. Now, the question is saying a possible value of theta if the horizontal distance of the projectile is given by this formula. These two answers, we're not looking, the normal question, if you're just solving, is state all the solutions between 0 and 2 pi. So this is where the word problem comes in. Okay, the question is asking, find a possible value. Well, these are possible values. So let's translate these into angles. So now I'm not, if they give answers, let's say this is a multiple choice question and we have answers and the answers are given in degrees. If the answers are given in radians, the answer will be one of these two. If it's not given in radians, it might be given in degrees. So what we would have to do is translate these into degrees. Pi over 12 times, how do we get degrees? We multiply by what we want over what we have, right? And we get these cancel, we get 180 over 12, okay? Which equals, sorry, I gotta get that. 180 divided by 12 equals 15 degrees. Okay, well, maybe that's the solution. And what if we had 5 pi over 12 and we wanted to know that in degrees? Multiply by 180 over pi. Those cancel. 5 times 180. 5 times 180 is 900 over 12, which equals 75 degrees. Okay, so my solutions could be either one of these because the question says find a possible value. And if I needed more solutions, what would I do? I would add the period. Okay, so you're not going to need to worry about this, but I could add the period, right? The period is 2 pi over 2, which equals pi, right? Equivalent period is 12 pi over 12, right? That's pi. If I wanted another solution, I could say pi over 12 plus 12 pi over 12 is 13 pi over 12. You know, I could get more solutions by doing what I know to do, add the period, but you will be just fine. Okay, so those are word problems that could appear on the quarterly. That's the type of thing that could happen. Okay, I will see you next class. Please finish your classwork and the study, the slides we did to review all material for the quarterly. You've got it. And the keys are posted, so check your solutions. All right, see you soon.